A little bit, guys, about the project. Just a quick reminder, Karen, that all the information that you need about the project is in the instructor folder. So if you guys go to the commercial project, and the name of the project is going to be Electrical Commercial Design Project, click on it. All the information I'm going to go over is under so-called work scope and schedule in the instructor folder. Everybody can see them. All these documents are the ones I'm going to be reviewing. Now the documents, guys, are right here. Also, I made a hard copy of them, not colored like mine. You guys are looking at it. So let me go ahead and look at the schedule. I already opened the schedule, so I'm going to go ahead and look at the schedule. Minimize it. Can you guys look at the first page that you have right in front of you on that package, and also on the network? I can't emphasize that all this information, this one is right here. It's called project schedule. The second one here, that's a document I'm opening right now. Cool. Okay. This is a commercial project development schedule. These are the milestones that you're supposed to do to finish this project, exactly like the milestones that we did, a little bit more involved than the residential. This is week 1. We're 7 through 11 is week 1. We're supposed to do project introduction and Revit setup. So by Friday, you will have a complete E1 through E10 setup in Revit. I'm going to start with that one. I have Hallberg coming tomorrow. After Hallberg leaves, they'll come typically here for an hour and a half. After they leave, my expectation, guys, is you will sit yourself in gear, get as much coffee as you want into yourself, and let's set up the E1 through E10. Very easy, like we did in CAD. If you do it, you follow with me, you do it fast, you do it quick, you do it right the first time, then you will be set up for the whole project. If you made any mistakes, big deal. We can fix them as we go. Okay, everybody understand? Like we did the CAD setup the first week we did, guys. Remember how we did XREF? We have a title sheet that we edited the title sheet, then we XREF the title sheet. And instead of XREFing here, we're going to do the term linking. Every time you hear Chad talk about X linking, it's an XREFing. So we're going to do Revit MEP 2013 setup E1 through E12. Hallberg is coming October 9. That's tomorrow, Wednesday. Every Wednesday, Hallberg is going to be here for the most part. So they will be here. I think 2 or 3 of their engineers will be here to introduce officially the project. The project is their project. The project is actually carrying their building, the building that they're officing in right now. So we will tour that building after we design it. They have a pizza party for us at the end. We go tour the same project that you guys designed, and you look and say, wow, is this a commercial? Is a kitchen that you guys were talking about? Look how small the kitchen is. So it's really interesting after you design it. Okay, week 1 again. We'll introduce the project. I will introduce my part. Hallberg will come and emphasize their part, and we'll do the setup. That's by Friday of this week. Week 2, that's next week. We're going to do project schedule and load calculation. We're going to take a step back from Revit for 1 week. Step back from Revit, and we will do our commercial load calculation for all the panels that we do in this building. I do have a template that I give to you, a PDF template like I did with the residential, because I think it's a little bit complicated, and we don't have time to, you guys develop the template, so I will give you all the code references with the template. Your job is to verify the code references, design the template in an Excel sheet, and give it to your friend Chad exactly like you guys did in the residential project for all the panels in the building. Microsoft project, guys, project schedule. Some of you have never used Microsoft project. I will walk you through how to do a Microsoft project schedule. I do have a template for you in a PDF file, because you have no idea how do you going to start, right? Do you? No clue, Chad, right? I would be no clue if I haven't seen it. I've done it before, you know what I mean? So what I do, I have a template, guys, in PDF file. Give it to you, and then I'll walk you through how to use Microsoft Project to build it in an hour or so, and then go ahead and build it. Make mistakes and let's correct them, right? So next week, we will step back from Revit. Then we do have on October 15, guys, we have power distribution speaker Todd Christensen from Color Hammer. The people who come here, guys, are professional, competent, content expert people. You're going to be dealing with those guys in the industry. I don't know, Dirk, if you've seen Todd at Michelle Cool Erickson or not. Jerry probably was there a couple of times. Yeah. So Todd's from Cutler Hammer. Cutler Hammer is one of the major electrical equipment manufacturer. One, you're going to be, when you deal with switch gears and panels and transformers, you will be specifying their equipment. So you want this guy in your site. You need to know him. So they will make your life as you become a project manager much easier. So he's going to be here. Typically, they come at 9 o'clock, guys, and they put a show for an hour to 2 hours. So get yourself into the gear of listening to other than chat. And they're really nice. They kind of diversify the knowledge, and number one, and they get you a break from me. So it's really, it's good, and they give you a lot of knowledge. Okay, so that would be, I think, October 15th. It's what's October 15th? Should be the Tuesday. Yep, the Tuesday. Then immediately Wednesday, Hallberg, one of the Hallberg guys will come here to follow up, riser diagram speaker. Typically Joe or Paul will come on Wednesday to talk about what is the difference between a riser and a one-line diagram. So they from a Hallberg point of view. So it's really cool. Anything blue, by the way, if you see a color blue, yours is not colored, but it is colored on the network. If it's blue, it's Hallberg. If it's red, it's an external speaker. If it's black, it's the task that you're supposed to do. That's how this schedule is. Okay, week 3. Week 3, that's in week 2. The week 3, guys, we're going to do one-line diagram and riser diagrams, low voltage riser diagrams, and one-line diagram. We're going to do them on week 3. We have Jerry Stanson from Square D. Motor control speaker. He's going to talk about motor controls. Jerry, the same thing. We'll put a good show on the 22nd of October. Hallberg, 23rd, will be here to follow up. When I say question and discussion, guys, they come and they say, "How, Matt? What do you think?" You know, and they look at your projects. If you have any question for them, great. If you don't have any questions, they visit with us and they leave. That's how they've been doing. Week 4, we're going to do. Week 4 is we're going to start laying out the power. Now remember, this building is a one-story office, commercial office building. Okay, one-story commercial office building, close to 12,000 square foot office building. So we're going to lay out the receptacles on it. We call it power layout, and the mechanical equipment, lay them out and circuit them. We bring Jeff Crowder from Davis & Associates, guys, to talk about visual software. So now we start prepping you to do the lighting. In order to do lighting, you need to learn software visual. So Jeff will come and walk you through visual. Before he comes, I will walk you guys through the software so you have all the little things you know it, so you go for more advanced things if you need to. Hallberg will be also that October 30th. Week 5, so this is week 4. Week 5, we have floor plan lighting. Lighting control speaker, Keith Severson will be here to talk about low voltage. Can you guys see we have a speaker? We have two different people coming every week. Keith Severson from RL. They will be here, an associate guys. They will be here to talk about lighting control speakers. How do you do a low voltage lighting control system? Have you guys done it with us here? We have a panel. I don't know if you guys wire it. 24 volt relays. You can control them with at 24 volt low voltage switches. So we'll talk about this one. He has modules that he brings with him. Really cool. Week 6, we're going to do site plan, power, and lighting. So we're going to do the site plan. Did we do? Floor plan. We have floor plan lighting. We're going to do the lighting floor plan. We have speakers about low voltage. We will do E4, which is site plan, power, and lighting, like we did the site for the residential project, except in Revit. We do have occupancy sensor speakers. I don't know how many of you guys have dealt with occupancy sensors. You walk in, light goes on. You walk out after 15 minutes, nobody moves in, light goes off. That's part of your energy code requirement as your energy conservation when you build a commercial building. To meet the energy code, you have to have it. So he talks a little bit about lighting control and lighting occupancy. Same thing, how big comes for discussion. Week 7, we will do the low voltage risers as well low voltage layout. So the risers and the layout will be in week 7, E7. It's called E7. We do have a fire alarm and security system speaker. Kevin Upitz from Simplex and Grinnell will be here to talk about. Those are the content experts. You can see, guys, we pick the content for every topic. talk about same thing, fire alarm and security system. Halberg will come after the second day. In week 8, we have a generator, an ATS, and energy code. You will be required, guys, to size the generator with the software and the energy code with the software calculation. We bring Jerry Boggs from Interstate to walk you through the science of generators, right? What do generators do for a living? How do you size them? He put a really good 2-hour show about almost that he does for engineers, not just for your beginners like you. It's a really good show about generators. Okay, so that will be in week 8. Week 9, we have panel schedule, lighting schedule, and the equipment schedules. This is E8, E9, and E10. All these schedules, you're going to put them in E8, E9, and E10. We'll do have an industry field trip, not decided yet. We are hoping to have a field trip that day to be determined. And then Halberg will be here. Week 10, we have power system analysis and specification, guys. That's when I walk you through SKM Power Tools for window to do a short circuit. Then on December 11th, we will go tour and have a pizza lunch at Halberg. They are in White Bear Lake. Everybody knows where White Bear Lake is, St. Paul area. So we'll go there. We typically go there around noon. At around 11 o'clock, we tour for 1 hour. We have pizza lunch and we'll go home. The last day to submit the project is December 20th, just before the holidays, where you guys, you bring to your friend Chad Curdy a nice looking binder like this with every aspect of the project that you have done. We have December 18th is set right now for the presentation. That's when we invite the electrical industry to witness your presentation. We have every one of you guys is a team now, so you're going to end up with 5 presentations. Each one of you will individually present. The way we do the presentation, guys, you will present one aspect of the project. So I'll ask you to do lighting for the whole project. So you do lighting for the site, lighting for the lighting layout, lighting sizing, everything lighting. You'll do power, you'll do low voltage, you'll do calculation, you'll do motor generator. So one aspect. So it becomes less repetitive. Instead of you do the whole thing and then you go over it again. And so we make it more exciting. Everyone will talk about different tasks. Cool? And I will assign you the tasks as we move on. Any comments, any question about the schedule? So this is the deadline that we're supposed to live by in these 11 weeks. Any comments, guys? Any questions? If you follow this, guys, you're gonna see the same thing. The residential project was kind of a mini part of this because it was a smaller project. The industrial project is gonna be exactly the same thing for a different building. So that's the schedule. Let me close the window. I'm going to minimize the schedule. These are the first 2 pages. Then I'm going to go to the second page, guys. If you click to the second page, you're going to find a document. I call it design build. Can you do me a favor? Make sure you're looking at the right document here, the second page. It's called ECDM 2110 Final Design Build Project. You guys had one for the residential project, if you remember. If somebody asked you, Matt, to design a commercial project, you're insane. It's like asking me to have a plan right now for a heart surgery. If somebody says, well, Chad, here's a patient, can you have design a plan to open that guy's heart? I say you're insane. I've never done it before. Now this is, give me a plan or come up with a plan, Chad. I have no idea where to start, right? I can give you a couple of crap, but what you're looking at, guys, is a plan to design the project. Without this plan, it will be almost impossible to design this project. Almost. I mean, almost you have no idea, especially when it comes to the commercial projects, because the code does not cover the commercial project fully. It's a design engineered projects, so you need to have a narrative. So we're going to look at the narrative. Okay, commercial project consists of the following. The first thing we need to do with your friend Chad, guys, is we need a project schedule using Microsoft. You will have a project schedule. Second thing, you need to have a load calculation, again, using Microsoft. The third thing is design drawing using Revit MEP 2013. That's what your project is made of. A project, a load calculation, and a design drawing. Can you guys see that? Everybody can see that? Then we're going to use an NM, Minnesota Energy code calculation. We will use ComCheck software, even though it's not approved by Minnesota Energy Code. They have more requirement, but that's as close as we can get to playing with the energy code. A lot of other states adopt the ComCheck. So that's what we're going to use. Lighting calculation. Your project will include lighting calculation using visual software. Generator sizing, we're going to be using common software. Power system analysis, we're going to be using SKM PTW, the latest. Specification, using Word. Cut sheets, you have done cut sheets. You go online and find cut sheets and print them for Chad. What cut sheets, Chad? It's coming. Project presentation, you're going to do a Microsoft project, PowerPoint to do presentation. You must have a digital copy of everything that you guys do and mentioned above. You have to put it on a network. So when you do all your calculation, like we did the residential, have to be on the network. So I have access to it. And a binder. You're going to put all your stuff in a binder like this and give it to your friend Chad. So that's what the commercial project is. Requirement, there are two requirements. Requirement number one is the National Electric Code. We're going to use an NEC code book for this commercial project, but it gives you nothing. If you look at the NEC code book, it doesn't give you a whole lot. The most important thing is the attached scope, the scope requirement that we get from Hallberg. This is your blueprint to design this project. An engineering narrative or scope coming from a bunch of engineers who have done it over and over and over again, and they write a description of what you need to do, and they give it to you and say, do it. Without that description, you'll be lost. If you're doing hospital, guys, there's narrative for hospitals. If you're a commercial building, there will be a narrative for commercial building. If you're industrial, you have a narrative for industrial. What's a narrative? An understanding of what customers require in a similar building, because it's all driven by customers. What type of light we typically use in this commercial building? What type of receptacles do we use? How do we lay out the receptacles? These are not in the code. The NEC code but doesn't cover it. These are engineered. Separate lighting and power branch circuit. Another requirement, guys, we want the lighting and the power to be separated, even though the code does not require you to do that. In the residential, you guys did the same thing. We separate the light from the receptacle. A very good engineering idea. So if a short circuit to trip that receptacle, the light continues to be operating. Safety too. So that's a requirement. So the NEC code book as well as the Hallberg. Project schedule, Microsoft project, as you're going to be using Microsoft project to show the major tasks. And I'm going to go quick over this. The major tasks that you need from the design development all the way into the commissioning of the building. When we do estimating, these used to be very important when you do estimating. The crews that you're going to be working with, we have electrical crews will consist of 3 electricians making $33 plus benefits and 6 apprentices making $20 plus benefits. That will help you. It doesn't mean a whole lot to you, but when you start laying out your crews, when you do estimating and project management, you need to know, well, how many people am I going to be managing? What are my crews? So you're looking at 9 people. You're going to divide them into one way of dividing them into 3 crews, 1 journeyman with 2 apprentices, and you put them in certain locations to do certain jobs. We'll talk about this one when it comes. Okay, drawing sheets. These are the one that we're going to be setting up tomorrow, not today. We'll be setting up tomorrow. Sheet 1 or E1 is going to call the title sheet. That's what we're going to name it. List of electrical sheets, that's not the name, that's a detail about it. Sheet 2 is going to be simple. Sheet 3 is power riser. Sheet 4, site plan lighting and power. Sheet 5, floor plan lighting. Floor plan power is 6. 7 is low voltage. Floor plan systems, we call it. Telephone, data, security, fire alarm. 7.1. Now we have 7.1 is going to be low voltage system risers. 8 is going to be panel schedules. 9 is going to be equipment, lighting fixture, and control panel schedules. And 10 is details. You're going to end up with typically there are 11 sheets if you look at 7 and 7.1. So you end up with 11 sheets. One of them, there are 10 sheets, named 10 sheets, but one of them is split into 7 and 7.1. That's what we're going to be setting up, and that's what your project for this commercial project. Any comments about the Revit? Makes sense? Okay. Now, Revit MEP drawing setup. I will give you guys, this is how we're going to do the setup, and I'm going to go through this one. So basically, we're going to have a title sheet. We're going to import the title sheet to the project, and we're going to link the architectural project to the central file. So we will be doing that, as I said, tomorrow, where we want to link the architectural. I did this step for you guys. Architectural model should be linked to the central file. I did this for you already. Your file is linked. I can show you how to do that, but I need to do this one to make sure it works. I don't like you to do it because that's a substantial. Linking, what we're going to do tomorrow is we will do title blocks, work on the title block, build the title block, and insert the title block into all the sheets that we have. That's the setup. We call it import the sheets. And you're going to be, so we're going to do the oncoming components, oncoming to each sheet. We'll talk about this one when we set up. Okay, families. Unlike CAD, they don't use the word symbols. In CAD, we use symbols, right? Symbol of receptacle, symbol of light. Karen, in Revit, they use families. That's the term they're going to use to. We're moving from CAD with symbols into Revit with families. They are the same thing, named differently. So families will be provided by your instructor. I do have a family for you, family list. And also, all students will be required to use same families. I would like you to stick with the families that I gave you unless you really have a reason for not to. Symbols. Minnesota Energy Code, guys, we're going to be using CompCheck for the inside and the outside. We have a software using CompCheck calculation. Load calculation, we're going to use Excel. Here's a few things. We're going to use the main panel, receptacle panel, and lighting panel. We're going to have 3 panels in this building. One main, one for the lights, and one for the receptacles. How many panels do we have in the commercial project, in the residential? 5. One for every apartment and one common. And also the main. So 6, almost 6 of them. We're going to have only 3 in this project. 10% future. That will help you when you do load calculation. Generator sizing, we need, when you size a generator, 2 reports comes out of it. One is called load report and the other one generator size report. You are supposed to print these for me. Will make sense when we go through it. Minnesota Energy Code, you are supposed to do it on the exterior and the interior of the building. I'll walk you how to do that using CompCheck, even though it doesn't apply. Cut sheets. You need to provide cut sheets for all electrical component or part of the system going to the building. So the major components, here's the cut sheets that I would like you guys to provide. Very, very, Matt, my friend, very clear. Only these things I want you to do. Cut sheets about all lighting fixtures, generator, panels, ATS, CT cabinet, lighting control panel, fire alarm panel, and security panel. These are the things that we need to find only. No receptacles, no conduits, no wires. Lighting calculation. When we do lighting calculation, these are the 6 things that I would like you guys to print from this software. First floor plan view with calculation point, then 3D view, no calc, parking lot plan view, parking lot 3D, first floor statistics and fixture schedule, parking lot statistics and fixture schedule. It means grief to all of you now, right? It's coming, but be aware. Okay, when we go to power system analysis using SKM, these are all the stuff that I would like you guys to do in this software, and I will go over them as it goes. Project presentation, you will be required to produce a presentation, blah, 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 copy of the presentation, okay, so you need to, this is a few description, you will be assigned a task to present to the industry. Project submission or submittal, you guys will be submitting a binder with your friend Chad. It looks like this one. That will be your final project. You need to have the project cover sheet says ECDM 2110, commercial project, your name and the school name and the date, description. So when it comes to the project, guys, you ask me, what do you want? Here's all the description. That's why I said everything they need is here. The last thing is table of contents. Here's what the table of contents for this binder will say. Tab 1, project narrative, project schedule, design drawings, load calculation, Minnesota Energy Code calculation, lighting calculation, generator sizing, power system analysis, specification, cut sheets, presentation, and at the end, we have a little reflective statement that we add. What did you learn from this project? That's what the reflective statement. We have 11 weeks to finish this project, and it will be 100% of your final grade. Any comments, any question, guys? Any comments, any questions about the project? Comments, questions? Does it make sense? No, yes? So that's what you have in front of you. I like to walk you through it from the get-go. Now go, when you guys are done with that, there's another document called the scope. So I would like you to go to right in the front of you, you guys have printed. Start with this one, scope. Everybody can see it right here. After that, these are multiple documents stapled together, guys. Scope, 2600, scope of electrical systems. This is a Halberg document. That's how they do it. So I'm going to go very quick over this one because they're going to go over it tomorrow. Just to give you an idea, so here's what I would like you guys to do today. I would like you to read this document, so when they come tomorrow and highlight certain things, read this particular document. For example, working includes, it's a 10,000 square foot building with a 5,000 future. Be aware of this. Alternative, we would like to have an alternative for the lights, different option for light. Assumptions, here's all the assumption that we're going to have. Regulation, regulatory requirement, all the code apply that you need to pay attention to. Uniform Federal Accessibility Standard, Minnesota Energy Code, state and local codes, NFPA 101, life safety, NEC code book, International Building Code, all these. Now remember, when you are an engineer and you have a narrative, guys, not only the NEC code book will apply to you, but also all the other codes. So they have an engineer, you have to set all the other codes that you have to adhere to, not just the NEC code book. You're an engineer. Like American with Disability Act, you have to follow that one. It's not in the NEC code book. Actually, it will be in 2014. Part of it will be. Okay. Then, design criteria for lighting. Without this, Karen, you will not be able to design this project. So, receiving room 120. I want to bring to your attention just one thing, guys. Location, receiving room 120. So when you go into the Revit, it will or CAD, you will show a 120 room. That's called the receiving room. We need you to provide a 20-foot candle. Now, anybody understand what a foot candle is yet? That's a unit of measuring lights, illuminance. The higher the foot candle, the more bright the place will be. The lower the foot candle, the more dark and dim the place will be. For example, in a parking lot that's not lit well, you're looking at 1 foot candle. Right here, where you're looking at Matt, my friend, right, and where your arm is, you're probably looking at 55 to 60 foot candle. If you're right close to the light, 55 to 60 foot candle, compared to a dark parking lot with 1 or 2 lights in it, 1 foot candle. Does that make sense, guys? To give you comparing foot candles. The type of the fixture is called wraparound fluorescent fixture. It's ceiling mounted, controlled by a ceiling mounted occupancy sensor. Now, the question would be, how the heck am I going to find a wraparound fluorescent fixture, Chad, when I've never done that? I gave you guys, Adam, can you grab the book, one of these books that says Lithonia now? Not this one, the one underneath it. Yep. Okay, raise this one up a little bit. This is the book that we're going to be using, guys, to pick up all the lighting fixtures. Now, you have no idea how to find a wraparound, right? I made it easier for you. I will give you a list of pages where to find each and every one of these fixtures in the book. Did you guys hear me? Very, very important. So go all the way 1.5 for all your lighting description. I'll let Halberg talk a little bit about these. 1.6, lighting control panel. We will provide a lighting control panel to control the system. 1.7, conference room 1, 2, and 3 location room dimming system. We need a dimming system in the conference room, not only just lights. We need to be able to dim it. 1.8, design criteria for the power. Now we're done with the lights for every single location of in the building. You can see when we did the lights, we went into the lighting studio, into the bookkeeping, into the mechanical room. Every single occupancy, we're telling you what type of fixture to use there from experience. So your job, Karen, is when you get a project like this, you say, okay, does the project has a canopy? Yep. Or here's a fixture that I used with Chad when we did a canopy, right? Does this project have an exit door? Yep. Here's a fixture that we use with Chad for exit doors. See what I mean? You start using these as examples. Even though your project, when you work on it, might not be like our project here, but it will have the same functions, the same rooms, similar rooms. Okay. We'll go to the conference room. We did the 1.8 design criteria for power. This will tell you where do you put. If you go to the NEC code book, Adam, right now, and find me in the NEC code book, where does it tell you to put how many receptacles do you need in an office building? There's nothing in the NEC code book that will tell you how many receptacles do I need in an office building. Nothing. So how am I gonna design it? Scope, narrative. In the engineering scope, experience, people who have done that before, they've done it this way and it works for years, right? I mean, with some changes. For example, receiving room 120, we're going to have one receptacle for every 1,000 square foot. Standard, the type is standard. Standard or GFCI? Okay. Restrooms 113 and 114, we want to have one receptacle per 2 sinks. If there are 2 sinks there, we'll put a receptacle there, and it's going to be a GFCI. It's going to be a GFCI. Oh, let's not just change it. GFI or GFCI. That's the type of the receptacle. Anyway, so you can walk right through all these places, guys, and how many receptacles do you need. And Halberg will talk about this one a little bit more in details tomorrow. But that's how receptacles in every area. 2.1, building equipment. When you go into CAD tomorrow, guys, when we start looking at CAD, you will see an item number 12. Now, what the heck is this, Chad? What is that? It says 12 on it. If you see 12, it's actually a copier. They want a copier here. So if I want a copier here, what does that lead you to? I need a receptacle, okay? Item number 13, laser printer. What do you need for it? A receptacle. 15 and 14 are shelving units. Shelves. Do I need a receptacle for shelves? No. It will identify the owner equipment into this building. Who cares? It will give you a hint. Do I need a receptacle or not for this piece of equipment? Okay. So print room, room by room, identifying all the stuff in it. Then you go into 2.2, electrical service. In the electrical industry, Brian, and you work for Excel, the first thing you do when you design a building is you need to know what type of a voltage and do I need for this building? That's question number 1. What type of voltage? If it's dwelling, residential, 241/20 typical, single phase. If it's apartment buildings, you have 2 options. 241/20 single phase or 281/20 3 phase. If it's an office building like the office building that we have, you have 2 options typically. Either you actually 3 options. You can either use 241/20 single phase or 281/20 3 phase or 482/77 3 phase. 3 phase is superior to single phase. So when you go commercial, your option number 1 to be 3 phase, unless they don't have 3 phase in a tiny little dentist office here that doesn't have a commercial 3 phase, you feed it for single phase. Okay, here's the power that we decided to use. It's a 281/20 3 phase 4 wire. That's the power system that we use. It's not 120/240. It's a 3 phase 281/20, very common for this size of the building. When do you use 48277 then? The bigger the building, the more likely, size-wise, square foot. This is a 10,000 square foot, guys. 10 to 15,000 square foot commercial buildings, typically 208, 120, perfect for them. You go higher than that, you start jumping into 48277. Why? It's more efficient going to a higher voltage. We'll talk about this as we move to. But be aware, this is a 208, 123 phase system building. You haven't done that with me yet, right? Okay, and we are to include a 5,000 square foot future expansion on this building. Here's what you need. You have to have a service entrance distribution panel, the main panel. Then you are to have a lighting panel, a receptacle panel, and air handling unit, condensing unit, boiler pump 1 and 2, auto transfer switch to feed loads of the generator. All these will be fed from the main panel, the main distribution panel. Okay. Later on, this will help you guys build your riser. Transient volt suppression. These are, talk about this one, you have to have a device that's a surge protective device is called. Electrical power distribution system. Your system is going to be 208, 120 for lighting and receptacles. Mechanical equipment. 2.5, guys, will get you all the heating, cooling, and ventilation equipment in this building, right? How would you know what type of air handling unit do you need here? No idea. That's coming from the mechanical engineers. For example, provide power for the following mechanical equipment. Air handling unit. It's a 15 horsepower, 208, 123 phase. Division 26 to provide VFD for the unit. C cut sheet. There are cut sheets, guys, so we need to see the cut sheets. We'll show you the cut sheets there. And I'm not going to read all of them, guys. You can see boiler pump, all the mechanical equipment in this building. You're required at least to power them, and sometimes to control them, and sometimes to provide a disconnect for them. Minimum power. Then some of them require also control, and other also require disconnect. How do you know which one require what? You're going to read this narrative. Okay, so that's all your mechanical equipment. Standby power system. The loads in, okay, so provide a standby generator to handle the building electrical loads, including future. So you are to provide a generator to back up the whole building with an auto transfer switch. Provide an auto transfer switch to pick up the whole building. Security system. Here's a description of the security system that we need. We need a main security panel, door contacts. You guys are familiar with what we did, similar to what we did in residential. Fire alarm system, main control panel, annunciator panel, manual pull station, audible, visual devices like these. So these are the requirements for the fire alarm system. I'm not going to go over details on them. Technology raceway system. This is for, you are to provide conduits and boxes and devices. If you read through it, it says the requirement only require you guys to provide conduits and boxes. I am adding devices too. For example, receiving room 120, one wall phone you need. So that will tell you where do you want to put your phone and data as well as your TV, if any. Ladies and gentlemen, and that's the end of the electrical scope. How big tomorrow, guys, will walk you through, talk a little bit in details about it before we start doing it. So go all the way back to that page, okay? Then you're going to see cut sheets about your mechanical equipment. Can you guys go to the cut sheets? The cut sheets, I'm going to go open the cut sheets. Okay, here's the first cut sheet that you're looking at. These, Derek, when it comes to mechanical equipment, you and I are not qualified to size a condenser or an air handling unit or a chiller. We depend on our fellow mechanical engineers to design these systems for us. And they have to provide a cut sheet for it. For example, the air handling unit has a cut sheet. They're giving us a cut sheet for it, which gives you the most important thing is the electrical here. It says 15 horsepower. Can you guys see that? And it's running a 208 3-phase. Motor RPM is 1800 RPM. Will be less than that. So that's your air handling unit. Cut sheet about the air handling unit. If you go to the next one, next page, all the cut sheets for the rest of them, guys. Let me just go quick. There you go. Condensing unit. Okay, so air handling unit. We don't want the air handling unit because we change it over the years. Here's your condensing unit. Can you guys see condensing unit? This is a cut. Everybody can see that, what you have in front of you here? This is a detail about the condensing unit. How are you going to use these information? This is FYI only. For example, here's the type of the condensing unit that we're using. It's normal 20 ton. If you go here, the voltage actually is the wrong voltage here, so we're going to pick up a voltage right, the one above it. Can you guys see the one above it? 230 three-phase. This is the type of the condensing unit that we're going to be using. Can you guys see that? Who cares? You're going to decide a disconnect, an overcomputation devices, and a conductor for this piece of equipment. Do you guys remember the minimum circuit ampacity that you did with Chad last project? It's right here, minimum circuit ampacity. The maximum fuse, do you guys remember the maximum fuse? They're right here. Unit rated load amps, right here. So all this information will be helping you guys to do the load calculation and size for the equipment. Keep going. The second future condensing unit, this one is the future, a smaller baby. Here's a description for it. I'm highlighting here, Derek, the 480. Can you guys see 460? We used to run this project 460, so do me a favor. The one that we're going to be using is the one above it. Is it right here, 208? We'll do that when we do the calculation. Okay, moving into future condensing unit. Here's your pump 1 and 2. Information about pump 1 and 2. Here's the horsepower highlighted for you. Next one is circulating pump. Can you guys see that circulating pump? Here's the electrical information about it. The third one is cabinet unit heater. Can you guys see that? Follow with me. Cabinet unit heater 1 and 2. Who cares? You guys are going to be sizing the branch circuit for it. Here's the electrical information about it. Horizontal unit heaters. Some of you said, what the heck are these, Chad? These are your heating, cooling, and ventilation equipment that you are supposed to power. In the house, it was easy. I told you guys there's an AC unit and go size it. In a commercial building, a mechanical engineer have to be involved in sizing the heating and cooling, guys. You need these cut sheets from them. Here's all the information about this one. Exhaust fan 1, 2, and 3. Can you guys see all the exhaust fans 1, 2, and 3? Here's cut sheets about them. And here's the information about these cut sheets right here. The horsepower for these babies. And the last one is file server AC, the air conditioning for the file server. Here's the information about it. It's a 208 full load amp 12.7 system, single phase. So that's the information about it. And that's basically it in terms of the cut sheets. In terms of cut sheets. Do you guys have another cut sheet? Do you have the map for Hallberg at the end? You don't have map?
I saw it
Online? Okay, we didn't put the map. The last thing I don't think I put it there is give us a map. I have a map for Hallberg. This is where the building that you guys are designing is located here in White Bear Lake. So just to give you an idea, this is where we're going to go to visit Hallberg office, and you will tour the same building that you're designing. Any comments, guys? Any questions? So that's basically what we're going to be doing for this particular project. Any comments, guys? So everybody understand what you have in front of you here? What you have in front of you? So what I'm hoping today, guys, from all of you, is to go through this material. Please read through it. I would like to give you a quick break and then maybe 15 minutes and then just show you the Revit. I don't want to start setting up today, just show you Revit and how it works and so forth. Make sure you have it ready for tomorrow. So let's take 15 minutes, stretch, do something, and then we'll do Revit. No sizing, no, we're not going to set up. I'm just going to walk you through a few things in Revit.